All right, so photovoltaic cells are called PVs, by the way. Okay, and what is the difference between a photovoltaic and a solar heating panel? So a solar heating panel is just basically something the sun shines on, and you might have something like water. You might have pipes going through this, right? And you might pump water through it. And so people use these for like swimming pools. You can heat the water in your swimming pool with solar. A lot of water heating is done with solar heating panels. You can also pump water through a solar heating panel and just store that hot water and use it, at night or something like that. And photovoltaics are, of course, the things you see. That's what everybody puts on their house. Those are things that turn the sun's energy into electrical energy, right? Okay. And what's interesting is that these things, these can be like 90% efficient because we're just turning sunlight into heat energy, right? Just a piece of metal in the sun does this. Your car does this. In Israel, somebody told me that people get old phone booths and they get the water tank out of an old water heater and stick it inside the phone booth, if you can just picture it. And they paint it black. And the water that comes out of them is just scalding hot, right? Because they'll just set them out in the sun. It's very sunny in Israel. Anyway, I don't know if they still do this in Israel. I know you can get, you can get something called a sun shower, which is basically a plastic bag. It's clear on one side, the other side's black, and the sun will shine into it. And in like an hour, it's warm enough to shower with, which is kind of cool. But anyway, photovoltaics are like, we're doing well if we get like 25% efficiency. But they make, electricity, which is very handy, right? Heat is sort of a low-grade, high-entropy sort of thing, and electricity is, kind of what would we say, a high-grade energy or something. All right, solar farm is made up of photovoltaic cells. The area is 2,500 meters squared. The average, and this when they say average, they're saying day and night, right, is 240 watts per square meter, right? So you have 25,000 square meters, right? Then you have 240 watts per square meter, right? So if you multiply those together, you'll end up with watts, right? So you're going to multiply those together, and you'll get a number that's, by the way, bigger than 1.6 megawatts, right? They're saying that the power output, this is the power input, right? The power input is the sun's energy, right? So the power input is the area times the intensity, right? The power output is 1.6 times 10 to the 6th watts. That's what 1.6 megawatts means, right? Okay, so calculate the efficiency. Well, efficiency is what? Output over input, right? Okay. An alternative method is the use of wind turbines. Determine the minimum number of turbines. It's not a very big number. It's fewer than 10, okay, that you need. And so what you're going to do is you're going to use the wind turbine equation. It's P power is 1/2 times the area times the density of the air, right? So the area of the frontal area is going to be pi r squared. Right, and then times v to the third, right? And you'll get a number between 2 and 3 times 10 to the 5th watts, okay? And then the question is, how many of those do you need to get this? You're just going to divide. So 1.6 times 10 to the 6th watts divided by whatever you get here. Okay, that'll tell you how many turbines. Now you're going to get a number that doesn't come out even. Okay, so what you want to do is, I guess, round up, right? Like if you got 5.1, you'd say, well, I guess we need 6, right? Then it says, explain 2 reasons why the number of turbines is likely to be greater than your answer. So you'll need more turbines, right? All kinds of things to talk about there. We talked about one thing, right? This is the total energy available to the wind turbine, but there's a very important reason that it can't harvest all that energy, right? We talked about it. See if you remember it. You can reason it out, right? Remember, this is if we take the air and make it stop, okay? Anyway, and there's 2 reasons. Yeah, I'll let you sort of think about that, right? Just think of ways that energy could be lost by a wind turbine. All right.